Okay, so we're just going to look at points of inflection. Now, basically a point of inflection is where there is a change in concavity. So, like if you have like a maximum and then you go to a minimum, somewhere along that point, there will be a change in the concavity. Now, points are concave up if y double dash is greater than 0, and they're concave down if y double dash is less than 0. So that would be like a smiley face, a positive x squared parabola, a sad face, a minus x squared parabola. Okay, so for example, if you had y say equals x cubed minus 6x squared plus 4x minus 1, and you want to find for what values of x is it concave up. So for what values of x is the curve concave up? Okay, so it'll be concave up when y double dash is greater than 0. So if you find y dash is equal to 3x squared minus 12x plus 4. Y double dash is 6x minus 12. So y double dash is 6x minus 12. So when 6x minus 12 is greater than 0, that will happen when x is greater than 2. And that's the values of x for which the curve is concave up. Now, it would be concave down if x was less than 0. That would be concave down. But there's a point when x equals 2 where it is neither concave up or concave down. And that's the point where we call that the point of inflection. So the point of inflection will occur when y double dash equals 0 and y double dash changes sign either side, like this point here at x equals 2. So one side it will be concave up or down. So this is down, and one side will be concave up. So it could look like that, or it could look up and then go to down. There'll be a point there where y double dash equals 0 that we call the the point of inflection. So this one here is concave down, and this one here is concave up. So y double dash is less than 0 when it is down. See that? And it is greater than 0 when it is up. And this one here, y double dash is greater than 0 because it's up. Y double dash is less than 0 because it is down. And right at the point of inflection, that's where it is 0. Okay, so that's just a point of inflection that is in between two stat points. There's another type of inflection, or a special type of inflection, that is also a stationary point, and it looks more like your cubic function. See how when you trace this is nice and smooth where it changes, whereas here you kind of go like this, concave up, concave down. But what happens if you actually ran like a tangent line through here, when you get to that point, the tangent line there would be horizontal. And that's because at that point, not only is y double dash equal to 0, but y dash is equal to 0, because y dash represents the gradient. And the gradient there is horizontal. So because the gradient there is horizontal, y dash equals 0. So for this particular type of stat point, it could be concave up that way, so y double dash is greater than 0, concave down on the other side, so y double dash is less than 0, and y double dash equals to 0. But the additional thing with this point is that y dash equals 0 at that point. It is also a stationary point. See these ones here, there's nowhere near that point or even on that point where the tangent line is horizontal. So this one here, when this happens, this is called a horizontal point of inflection. And so at that point, y dash equals 0, y double dash equals 0, and y double dash changes concavity either side. So if you look at like the three types of stationary points, you've got your maximum. So that's where y double dash is greater than 0. But if you did it with gradients, like with y dash is less than 0 that side and greater than 0 that side. If you're looking, sorry, that's not a maximum, that's a minimum. If you're looking at a maximum, y double dash is less than 0. That's if you're using y double dash. If you're going like this, y dash is greater than 0 to the left and y dash is less than 0 to the right. And it is equal to 0 at the stationary point. So this one here, this is using gradients. And this is using your concavity. The third type is your horizontal point of inflection. So the horizontal point of inflection looks like this. Okay, so when you find this, and y double dash will be equal to 0 at that point, but you have to check that y double dash changes sign either side of the point. So plus to minus, that would be concave up to concave down, or minus to plus. That's if you're using y double dash. But if you're using y dash, so if you're using y dash, which is the gradient, so this one's the gradient, this one's the concavity. If you're using y dash to look at the type of stat point, then basically when you put y dash into the table, you've got A0, A plus, A minus. What will happen is you get the same sign either side because the gradient either side is the same. It either goes plus to plus or it comes down and goes minus to minus. Okay, so how this comes into the big picture is first of all, you got to find the stat points and determine the nature. Okay, so basically you go, all right, find y dash, make y double dash equals 0, and solve for x equals a, x equals b. Find y, so you sub into the original, and then to determine the nature, that's where you've got two choices. Okay, if you use y dash, then you put it into a table, you put your points, x, y dash, and you go a and b, and there's 0 there, and you're putting into y dash, so make sure you put the first derivative there. That's a minus, a plus, and then say b plus, so going either side. So what you're interested in here, if it goes from plus to plus, then it would be a horizontal point of inflection going like that. If it went from minus to minus, it would be a horizontal inflection, but it would be going downwards. If it goes from plus to minus, that would be positive gradient to negative gradient. That would be a maximum. And if it went from minus to plus, it would go like this, and that would be a minimum. So you basically, if you, like you did this and you're drawing it, you got A plus, oh sorry, A minus, A plus, B, and then you go more than B, 0, 0. So you get plus, plus, minus. That means it would go positive gradient 0, positive gradient 0, negative gradient. So your curve will basically look like this, going up and coming down. So it has a horizontal point of inflection and it has a maximum as its stationary point. That's actually how you use y dash, okay, to find those stat points. Now, notice that on this curve here, in between your two stat points, there is a change in concavity. Because this one goes down and then it goes up. So y double dash is greater than 0. Oh, sorry, less than 0. Y double dash is greater than 0 because it goes up and that one's down. And this one goes up and then it comes back down again. So y double dash is less than 0. So that is just what we call an inflection. So when we just call it an inflection, it's just a normal everyday inflection. This one is an inflection, but it's special type, and that's why it's called a horizontal point of inflection. It's a special type because it is also a stat point. This one's a stat point as well, but it is not a horizontal point of inflection. Okay, so finally, if you want to use y double dash to determine the nature, then once you've got y dash equals 0, solve for x equals a and x equals b, and then you sub into y equals f of x for y. So you find f of a, and then you find f of b. Once you've done that, then the next step is you need to determine the nature. So in order to determine the nature, the steps that you use, if you're going to use y double dash, you find y double dash, you sub in x equals a and put in y double dash. Okay, and then you sub in x equals b and you put it into y double dash b. So basically, if y double dash turns out to be positive when you do this, it is a happy face, like a positive x squared. It is a minimum turning point. If y double dash is less than 0, then that would be a sad face or a negative x squared, so a maximum turning point. If y double dash happens to equal 0, that means it must be a stat point plus it is an inflection. So therefore that equals a horizontal point of inflection. So with all inflections, when you go through y double dash, you then have to check y double dash changes sign, because what you're really doing there is you are checking the concavity changes. So you have to put it into a table, but make sure you label your table. So your table needs to have y double dash, and there's say a plus, a minus. You do it for each point. And what we're interested in here is when we sub it in, that it goes from like positive to negative, or it goes from negative to positive. Because when it's doing that, see, that would be negative to positive, because it's concave down to concave up, or concave up to concave down. Because remembering that y double dash relates to the concavity, and y dash relates to the gradient. So basically, say you had a curve like this. If I went through and did that, that's where y dash is 0. That's your stat points. There are 3 types. That's a hurry inflection. This one is a minimum, and this one is a maximum. The gradient either side, that's negative, that's positive. This one here is positive and positive. So do you notice even for the gradients, it goes from plus to minus for the maximum, goes from minus to plus for the minimum, and plus to plus for the horizontal point of inflection. If you look on the same graph, and I'm just going to mark this in green, so make it a bit thicker, you can see that all the way along to here, y double dash is less than 0, it is concave down. And then if you look at the next part from here, all the way around to about there, y double dash is greater than 0, concave up. And then here, concave down. Then finally, this part, concave up. So at these points here, they are all inflections. This one is just a normal inflection, this and this one, and that one there is your horizontal inflection. So your normal inflection is found by making y double dash equals 0 and solving, and then check y double dash changes sign with your box. The horizontal inflection will be picked up in your stat point. So y double dash and solve, and when you sub it into y double dash, it will be a hurry inflection, and you still have to do what you have to do for the other one, is you have to check y double dash changes concavity with a box.